Now we are going to define enveloping cylinder of the conicoid. Enveloping cylinder of the conicoid. In the conicoid, we are going to define enveloping cylinder. Now, already in course we defined enveloping cylinder. That same concept here we have to use. Just surface only changes. Here definition is, let us take a conicoid. I want to take it as some ellipsoid. Let us take a conicoid. Yes. Now let us proceed all parallel tangent lines to this conicoid. Let us define all parallel tangent lines to this conicoid, which forms a cylinder. Such cylinder is called as what? Enveloping cylinder of the conicoid. This is called as what? This total surface is called as what? Enveloping cylinder of the conicoid. Once again I am repeating. Let S is a conicoid. Then the set of all parallel tangent lines to conicoid forms a cylinder, which is called as enveloping cylinder of the conicoid. This is the definition of enveloping cylinder. Okay, now let us see problem here. Theorem here. It may be theorem number 4. Yes, see statement of theorem number 4. Show that the equation of enveloping cylinder. Show that the equation of enveloping cylinder. The equation of enveloping cylinder to the conicoid ax square plus by square plus cz square minus 1 equal to 0 in the direction of L, M, N, in the direction of L, M, N is ALX plus BMY plus CNZ whole square is equal to AL square plus BM square plus CN square into AX square plus BY square plus CZ square minus 1. This is your statement. Show that the equation of enveloping cylinder to this conicoid ax square plus by square plus cz square minus 1 equal to 0 in the direction of L, M, N. In the direction of L, M, N means in that one line will get now parallel tangent lines. We are proceeding now. Those lines direction ratios are what? L, M, N. That is the meaning of this one. That enveloping cylinder equation is what? Is ALX plus BMY plus CNZ whole square equal to AL square plus BM square plus CL square into AX square plus BY square plus CZ square minus 1. Yes. First of all, I want to plot a diagram. After that, we can proceed our main work. Right? First, from diagram for anode data, then you can proceed your given solution. I mean procedure. This is your conicoid. Yes. This is your required. This is your required cylinder, or you can call it as enveloping cylinder. Right? First, I want to take the conicoid. Given conicoid is what is that one? Ax square plus by square plus cz square. Ax square plus by square plus cz square minus 1 equal to 0, and In the statement, what they given no? L comma M comma N are direction ratios of the generator of the cylinder. Otherwise, enveloping cylinder, whatever that means. This line direction ratios are what? This line direction ratios are what? L comma M comma N in the statement they give. Now, I want to take a point P, which is what? My x1, y1, z1 on the cylinder. Let us take a point P, x1, y1, z1 on the cylinder at end stages. Let us define locus of this point P1. You get this cylinder equation, right? Now I want to write this point P here. Let P x1, y1, z1 be a point on the cylinder or enveloping cylinder. Any word you can use, right? In the next step, I want to define this line equation, generator equation. I mean, I am going to define the equation of a line passing through point P and having direction ratios what? L comma M comma N. That I am going to proceed here. The equation of a line means it is generator. The equation of a line passing through the point P x1, y1, z1 and having direction ratios L comma M comma N is, that line is what? X minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. This is this line equation. In the next step, I want to define a general point on this line. For that, let us take this is equal to some lambda, right? To define general point, let us take lambda. Now define a general point on above line. General point on above line is yes, that general point I am denoting with capital A. What is that? X is equal to x1 plus lambda L, y is equal to y1 plus lambda M, and z is equal to what? Z1 plus lambda M. That is general point on this line. Again, general point on this line means what? Anywhere on the line, I want to fix that at here, at point of contact. This is I want to take capital A. Whenever it is here, is it on your given conicoid or not? I mean, in the next step, I want to take that capital A is a point on the given conicoid, right? Let here I want to take the diagram on this. This is your point of contact, right? Let capital A is a point on the conicoid. You know what is that conicoid equation? Ax square plus by square plus cz square minus 1 equal to 0. This implies r. So that anyway you can write now. Yes, replace x with this, y with this and z with this here. What we get now? A into x1 plus lambda m whole square plus b into y1 plus lambda m whole square plus c into z1 plus lambda m whole square minus 1 is equal to 0. In the next step, write this one as one quadratic equation in terms of lambda. I mean, first go for a plus b whole square expansion, then write down lambda square coefficient separately, lambda coefficient separately, and free from lambda coefficient. This b square term gives what? Lambda square term or not? Clearly I am writing a square plus bm square plus cm square into lambda square. Already the previous condition we proceed. Next 2ab term gives what? Lambda coefficient. This 2 and lambda are taken outside. A L x1 plus b m y1 plus c m z1 into lambda. 2 lambda will be taken outside. Under a plus b whole square 2ab term is this. plus b square term is what? I mean b square means a square term here. It is what? ax1 square plus by1 square plus cz1 square minus 1. This is free from lambda. It is equal to 0. Any problem is there? Again once look more. Is it this line? Is this line touches this conicoid or not? Whenever this line touches this conicoid, roots of this equation are equal, hence its discriminant becomes 0. Use that condition. For that, this line equation I am taking number 1. Right? We know that line equation 1 touches given conicoid so that the roots of above equation are equal, hence its discriminant becomes 0. Hence its discriminant becomes 0. You know what is discriminant? B square minus 4ac equal to 0. I am writing that. This implies b square is what? 4 into alx1 plus bmy1 plus cnz1 whole square minus 4ac is what? al square plus bm square plus cn square into c is what? ax1 square plus by1 square plus cz1 square minus 1 is equal to 0. Any doubt with this one? Right? Here you can divide it 4 and take this total negative term to other side and then define locus of P. Basically P is a point on the cylinder. If you can define locus of P, you get cylinder equation. For that class here define locus of P and take this negative term to other side. Both steps at a time I am doing. The locus of point P is, yes, locus means replace x1 with x, y1 with y, z1 with z in this. alx plus bmy plus cnz whole square is equal to this negative term I am taking on the other side now. al square plus bm square plus cn square into ax square plus by square plus cz square minus 1. Is this equation or not? This will be your equation of enveloping cylinder. This is equation of enveloping cylinder. alx plus bmy plus cnz whole square equal to al square plus bm square plus cn square into ax square plus by square plus cz square minus 1. This is about your theorem number 4. Yes, let us see problem 1. From here, every problem is important. From here, a point P moves. So that the section of the enveloping cone, the section of the enveloping cone of the ellipsoid it is x square by a square plus y square by b square plus z square by c square is equal to 1 with P as vertex by the plane z equal to 0 is a circle. Show that P lies on the one of the conics. Show that P lies on the one of the conics y square by b square minus a square, y square by b square minus a square plus z square by c square equal to 1, or either this or other one is x square by a square minus b square plus z square by c square equal to, actually these two are answers. After proceeding our simplification, you must get either this answer or this answer. In two cases you have to proceed. But once you go through your question, a point P moves so that the section of the enveloping cone of this ellipsoid with vertex as P by the section of the enveloping cone by this plane z equal to 0. That means whenever you can take intersection of plane, this z equal to 0 plane with this enveloping cone, what we get? Circle. You must get circle, that common area. Then what we have to show? This P must lies on either this equation or this equation. Means let us define locus of P. That locus of P gives either this equation or this equation, that we have to show. This is complete outlook of the question. Yes, see step by step your solution. First of all, I want to take given conicoid. Given conicoid is given ellipsoid, otherwise you can use conicoid or ellipsoid. Given ellipsoid is x square by a square plus y square by b square plus z square by c square is equal to 1. Now let us take this point P is what? Some x1, y1, z1. What is z1? Vertex of the cone, right? Let P x1, y1, z1 be vertex of the cone. Our required cone vertex is what? P x1, y1, z1. According to this P, I want to define S11, S, all those things. For that, let us take this conicoid or ellipsoid is S1, S equal to this right better. This take notation is what? Yes. Okay, now? From this, can you write S11? What is that? X, x1 by a square plus y1 by b square plus z1 by c square minus 1 according to this one. x1 by a square plus y1 by b square plus z1 by c square minus 1. And what is S11? You can replace your x with x1, y with y1, z with z1. x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. Right? After this one, let us define equation of enveloping cone. Let us take equation of enveloping cone. What is that? S1 square equal to S into S11. The equation of enveloping cone is, means we are defining first enveloping cone equation. The equation of enveloping cone is, yes, it is what? S1 square is equal to S into S1. This implies S1 square means what? This one. x1 by a square plus y1 by b square plus z1 by c square minus 1 whole square is equal to what is S1? X square by a square plus y square by b square plus z square by c square minus 1 into what is S11? Is it this is S11 or not? x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. Any problem is there? S1 square is equal to S into S1. Yes, we defined this enveloping conic question. But after this, what they want now? Let us put Z equal to 0 here. That forms a circle. I mean, first substitute Z equal to 0 here. Given that Z is equal to 0. This implies, I mean, here we are substituting Z equal to 0. Z only, not Z1. Z equal to 0 we are using. It is x1 by a square plus y1 by b square. This Z is 0, no? Minus 1 whole square is equal to, here also Z 0. X square by a square plus y square by b square minus 1. This you can write as it is. What is that? X1 square by a square plus y1 square by b square plus z1 square by c square minus 1. Right? Just we put z equal to 0. Here we got reduces above equation like this. In the next step, let us take this total term to other side. I mean, this minus this I am writing. This implies x square by a square plus y square by b square minus 1 into x1 square by a square plus y1 square by b square plus z1 square by c square minus 1 minus this one. x1 by a square plus y1 by b square minus 1 whole square is equal to 0. Any problem here? But whenever you can take z equal to 0, this represents what? Circle. But when do you say it represents a circle? To proceed, it is a circle. The coefficient of x square should equal to coefficient of y square in circle. And there is no x into y term in the circle. That means here you must take coefficient of x square equal to coefficient of y square and the coefficient of xy equal to 0, because this represents the circle. Given that above equation represents a circle, so that the coefficient of x square is equal to coefficient of y square and the coefficient of xy is equal to 0. These conditions used. For that, in this total expression, write first coefficient of x square and then take coefficient of y square. And write actually do complete product, then write a coefficient of x square, but that work is too heavy for you. That's why directly I am writing. You also practice like that. X square means, is it this into this x square coefficient or not? X square coefficient gives what? x1. I mean directly I am writing. This into this total thing gives x square coefficient or not? It is what? 1 by a square into this total thing. x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. This x square into this total thing gives x square coefficient. That is your x square coefficient in this one. Here must go through x square coefficient. Expand this one, a plus b minus c whole square. A square term gives what? X square coefficient or not? It is what? Minus x1 square by a power 4. x1 square by a square whole square is what? A power 4. This total thing is what? The coefficient of x square or not in this complete expansion is equal to the coefficient of y square. Coefficient of y square means what? This y square into this total term is 1 by b square into 1 by b square into what is that? x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. 1 by b square into this total thing gives what? Y square coefficient. Here it is what? B square term. It is minus is there now. Here also actually minus. Okay, written minus now. Yes, minus. Next one. This term gives b square term gives what? Minus of y1 square by b power 4. coefficient of x square is equal to coefficient of y square. And this is first one. No? Next one is what? No? The coefficient of xy becomes 0. Coefficient of xy means what? No? Where we get? There nowhere xy term. Here you get no. 2ab term gives xy coefficient or not? 2 into x1 by 1 by a square b square. These two product only gives x into y term is equal to 0. Any problem is there? No? Yes. Next, if any term can cancel, not cancel it. No? I think x1 square by a power 4 minus x1 square by a power 4 gets cancelled. No? These two terms. Here also y1 square by b power 4 minus y1 square by b power 4 gets cancelled. Right? Next, just I am doing simplification. This implies I am writing like this. No? y1 square by a square b square plus z1 square by a square c square minus 1 by a square is equal to y1 square by a square b square z1 square by a square c square minus 1 by a square is equal to this what? x1 square by a square b square or b square a square plus z1 square by b square c square z1 square by b square c square minus 1 by b square. This is one result. No? And here one should know. 2 take on the other side. 0 by 2 becomes 0. Cross multiplication do what? x1 y1 is equal to 0. Any problem with this? Just be careful with this simplification part. If you can expand it, it is full of confusion. That's why don't expand, practice like this. In the next step, a square b square terms combination take. I mean in between these two things, let us take 1 by a square b square take common. It is what? y1 square minus x1 square y1 square minus x1 square by a square b square y1 square minus x1 square by a square b square plus here z1 square by c square take common. z1 square by c square if you can take common 1 by a square minus 1 by b square. Just I am writing combinations. These two is this one. These two combination is this. And let us take this one to other side. No? Then this is equal to what? 1 by a square minus 1 by b square. And this you can keep as it is. x1 y1 is equal to 0. Right? Still I want to remove few lines more because these are not required. I want to use it. This simplification practice maximum time is not that much of easy simplification. First of all, I want to put those lines more. Here, this I want to write as y1 square minus x1 square by a square b square plus z1 square by c square z1 square by c square into here take a square b square common in the denominator. What we get to? B square minus a square b square minus a square is equal to here also a square b square take common. It is what? B square minus a square and other relation is what? x1 into y1 is equal to 0. This keep as it is. Second one already simplified. Here let us take this common and cancel with this. Right? After that divide with b square minus a square on both sides, especially for this relation. Dividing with b square minus a square on both sides in the first relation only. Second one already simplified. Make it. What is that one? y1 square minus x1 square by b square a square plus z1 square by c square because these two gets cancelled is equal to this way. This becomes what? 1 and other relation is directly what now? X1 into Y1 is equal to 0. Now I want to remove these lines because these also no need. Okay, now let us take locus of P now, because the locus of P, what is our condition? P lies on this means whenever you can form locus of P, you must get this and this, both expressions in different situations, right? For that I want to take locus of P now. The locus of point P is, locus means what? Replace x with x, x1 with x, y1 with y, and z1 with z in both expressions. We have y square minus x square by b square minus a square plus z square by c square equal to 1, and x into y is equal to 0, right? Any problem that this I don't know what is the number one in the middle. I didn't take any number one. If you can take, continue it for my convenience. I don't know what is the number, I take it one. That's why I am taking big expression one for my convenience. But here one step one. X into y equal to 0 means what? Either x equal to 0 or y equal to 0. In both situations you have to proceed this one, this expression. But clearly I am writing now. X into y equal to 0 implies either x equal to 0 or y equal to 0. Now we have to proceed our work in two cases. In case 1, let us take x equal to 0, substitute here, you get one of the result now. In case 2, take y equal to 0, substitute here now, you get one of the result. That completes the total question. Case 1 I am taking. Let x is equal to 0. From big expression 1 implies here substitute x equal to 0. What we get to? Y square by b square minus a square plus z square by c square is equal to 1. Is it your one of the one or not? This one you got now? Now go for case number 2. What is that case for? Let us take y equal to 0 now. Let y equal to 0 now. Substitute that y equal to 0 in big expression number 1. Substitute here y equal to 0. What we get now? Minus x square by b square minus a square plus z square by c square is equal to 1. Minus x square by b square minus a square plus z square by c square equal to 0, because y equal to 0 we substitute. Minus take here. I mean the same relation you can write as what? X square by minus into minus to take inside of this denominator. A square minus b square plus z square by c square is equal to, this is another locus of P, either this or this one. That completes the condition, because these are either or conditions. Due to that, either this relation or this relation will get to. This is one of the important problem. But under calculation part, be careful now. Same like me, you do yourself, practice at home, same like me, right? Next question now. It is a practicalist question. It can be 27 times. Practicalist question number 27 now. List. If the section of the enveloping cone, if the section of the enveloping cone, if the section of the enveloping cone of the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1, whose vertex is P, whose vertex is P by the plane z equal to 0, by the plane z equal to 0, is a rectangular hyperbola, is a rectangular hyperbola, is a rectangular hyperbola. Show that the locus of P is locus of P is x square plus y square by a square plus b, x square plus y square by a square plus b square plus z square by c square is equal to 1. It is same as previous question, same like your previous question, but the difference between that and this is whenever you can cut this conicoid z equal to 0, right? You get there it is a circle, here it is rectangular hyperbola. Rectangular hyperbola means basically the coefficient of x square plus coefficient of y square. If z axis is there, coefficient of z square is also 0, but z equals 0, that's why there is no z axis here. After getting the result, let us take the coefficient of x square plus coefficient of y square equal to 0 and then from locus of p you get this one. It is similar to previous problem. Here circle is there in the previous question, now in the regular question what we have, running question, rectangular hyperbola. That is the only difference, right? Procedure is same like that. First take your given conicoid. Given conicoid is x square by a square, conicoid or ellipsoid. Use your board or given word, given ellipsoid. Ellipsoid conicoid, no problem. Ellipsoid is x square by a square plus y square by b square plus z square by c square is equal to 1. And P point I want to take as x1, y1, z1, be vertex of the cone. Right? And I want to take this is some s equal to proceed notations. Ellipsoid s is equal to x square by a square plus y square by b square plus z square by c square minus 1 equal to 0. Instead of taking equal to 1, it is confusion. From this you can define according to this point P S1 and S11. This implies what is S1 x1 by a square plus y1 by b square plus z1 by c square minus 1, and what is S11? x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. This is S1. Now define equation of enveloping cone here. The equation of enveloping cone is you know that S1 square is equal to S into S1. This implies S1 means this one, x1 by a square plus y1 by b square plus z1 by c square minus 1 whole square is equal to S. What is S now? X square by a square plus y square by b square plus z square by c square minus 1 into S11 is what now? x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. Any problem is there? x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. Right? Now in the next step, take all the terms to one side. Again do the same one. But before doing that, I want to take for given condition. Given that z equal to 0, substitute here z equal to 0. Given that in the question z equal to 0, this implies this relation reduces to what now? x1 by a square plus y1 by b square, z is 0 now, minus 1 whole square is equal to x square by a square plus y square by b square minus 1, because z is 0, into remaining part is same thing, x1 square by a square plus y1 square by b square plus z1 square by c square minus 1. In the next step, take all the terms to one side. These terms take on other side, right? This implies x square by a square plus y square by b square 1 into x1 square by a square plus y1 square by b square plus z1 square by c square minus 1 minus x1 by a square plus y1 by b square minus 1 whole square, right? But whenever you can take z equal to 0, it should be what now? It should proceed what now? Rectangular hyperbola. Take that condition. Given that above equation represents a rectangular hyperbola. In the intermediate level, you know, when do you say one equation represents a rectangular hyperbola, second degree equation? The coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. But here there is no z term. That's why what we take now? So that the coefficient of x square plus the coefficient of y square is equal to 0. Yes. Write the coefficient of x square common. That means 1 by a square, like previous problem. 1 by a square into 1 by a square into this total thing, x1 square by a square plus y1 square by b square plus z1 square by c square minus 1, that is x square coefficient. One more x square coefficient is there, minus this square gives what? X square coefficient, it is what? x1 square by a power 4. This is complete x square coefficient, right? Plus what is y square coefficient? This 1 by b square into 1 by b square into this total x1 square by a square plus y1 square by b square plus z1 square by c square minus 1, and here it is what now? This term minus this b square term minus y1 square by b power 4 is equal to 0. Any problem is there no? Now here this and this gets cancelled. Here also this and this gets cancelled, right? The remaining result write down properly. This implies y1 square by a square b square plus z1 square by a square c square minus 1 by a square plus x1 square by a square b square, this one, plus z1 square by b square c square, z1 square by b square c square minus 1 by b square is equal to 0, right? So now let us do simplification now. I want to remove these lines. I want to remove these lines. First of all, I want to proceed here in this box. After that, we can extend it. Just I want to subvert here, then we can go there. It is in between these two things. Let us take 1 by a square b square, you can take common one. It is what now? x1 square plus y1 square. This implies x1 square plus y1 square, x1 square plus y1 square by a square b square. Yes, this over now. This one and this one over now. Next, in between these two things now, let us take z1 by c square common plus, if we can take z1 square by c square common, then what is the remaining result here? 1 by a square plus 1 by b square, 1 by a square plus 1 by b square. Okay. Then these two terms I want to take on other side is equal to 1 by a square plus 1 by b square. Okay, no? Any doubt is there? This implies x1 square plus y1 square by a square b square plus z1 square by c square into, here take a square b square common, then it should be what? B square plus a square. B square plus a square is equal to, here also what? B square plus a square by a square b square. Any doubt is there? This a square b square, this a square b square, you can cancel with this a square b square. After that, divide with a square plus b square on both sides. Dividing with a square plus b square on both sides. Dividing with a square plus b square on both sides, we get what? X square plus x1 square plus y1 square by a square plus b square plus z1 square by c square is equal to 1. Any doubt? x1 square plus y1 square by a square plus b square, because we are dividing with this term, these two things gets cancelled. z1 square by c square is equal to these two things gets cancelled. After getting this note, simply define locus of point P. Just to go through locus of your point P, you get your required result. That I am writing because we are not having space. The locus of point P is, means here replace x1 with x, y1 with y, z1 with z. X square plus y square by a square plus b square plus z square by c square is equal to 1. Is it your required result or not? Right? This is about your question. It is similar to previous question. It is not a new question. Same like previous question. Next problem. Find the locus of points. Find the locus of points. Find the locus of points from which three mutually perpendicular tangent lines. From which three mutually perpendicular tangent lines can be drawn to the conicoid. Can be drawn to the conicoid ax square plus by square plus cz square is equal to 1. Right? Again, it is also same like previous question. Let us take x1, y1, z1 is the point 1. Right? And take this is s1. Now take s1 and s1. Define the equation of enveloping cone. Whenever you can take three mutually perpendicular, you must get enveloping cone. We are nowhere enveloping cone word, but we are going to use enveloping cone. Enveloping cone equation is what? S1 square equal to s into s1. After getting that, whenever that conicoid has three mutually perpendicular tangent lines, in that equation, coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. This is in your intermediate level concept. Whenever one surface has three mutually perpendicular lines, tangent lines, three mutually perpendicular tangent lines, in such case, in that equation, coefficient of x square plus coefficient of y square plus coefficient of z square is equal to 0. Use that condition and form locus of P, you get your required result. That is your above question. Right? For that, first I want to take given conicoid. Given conicoid is S is equal to ax square plus by square plus cz square minus 1 equal to 0. Let P x1, y1, z1 be a point. Right? Now according to this P, let us write S1. It is what? Ax x1 plus by y1 plus cz z1 minus 1. And write S11 ax1 square plus by1 square plus cz1 square minus 1, right? Now define the equation of enveloping cone. The equation of enveloping cone is, what is that one? S1 square is equal to S into S11. This implies S1 square means what? Ax1 plus by1 plus cz1 minus 1 whole square is equal to S is what now? Ax square plus by square plus cz square minus 1 into S11 is what now? Ax1 square plus by1 square plus cz1 square minus 1, right? In the next step, take all the terms to one side. In the next step, let us take all the terms to one side. This implies, I want to take this total term to other side. Then what we have? Ax square plus by square plus cz square minus 1 into ax1 square plus by1 square plus cz1 square minus 1 minus of axx1 plus by1 plus cz1 minus 1 whole square equal to 0. Now use the condition. Given that conicoid has three mutually perpendicular tangent lines, so that in this equation coefficient of x square plus coefficient of y square plus coefficient of z square equal to 0. Use that condition. Given that above conicoid has three mutually perpendicular tangent lines. Three mutually perpendicular tangent lines, so that the coefficient of x square plus coefficient of y square plus coefficient of z square is equal to 0, right? This implies, define first in this coefficient of x square plus this x square into this total term, a into ax1 square plus by1 square plus cz1 square minus 1 in this x square coefficient, one more term is there, this a square term minus ax1 square minus a square x1 square minus a square x1 square, that is x square coefficient, right? Next is y square coefficient. This y square means b into this total thing, b into ax1 square plus by1 square plus cz1 square minus 1, that is the here minus this one minus y square term, b square term, b square into y1 square plus z square coefficient, this c into ax1 square plus by1 square plus cz1 square minus 1 minus, here it is minus c square z1 square is equal to 0, right? Just simplify it and define locus of p, you get your required answer. Here this you can cancel with this you can cancel with this, and this you can cancel with this one, right? Next I want to write x square, xy square coefficient separately, y1 square, z1 square, x1 square, here it is what ab or ba, this is one x1 square coefficient, this is one x1 square coefficient plus ca into x1 square plus y1 square, here it is, here y1, ab plus y1 square coefficient here plus BC into y1 square plus z1 square coefficient AC, here z1 square, here plus BC into z1 square, and still remaining part anything is available, minus A minus B minus C is there. I want to take it to other side, A plus B plus C. Any problem there? No? This implies here take A common, A into B plus C into x1 square plus B into A plus C into y1 square plus C into A plus B into z1 square is equal to A plus B plus C, right? Is equal to A plus B plus C. After getting this, define locus of point P. The locus of point P is, it is what? A into B plus C x square plus B into A plus C y square plus C into A plus B z square is equal to A plus B plus C. This is your required locus of that point. Okay? This is about your